All right. Hey, APES scholars. Welcome to the review for units 5 through 9 because we didn't finish unit 5 last night. It's supposed to be 6 through 9, but we got to finish up unit 5 tonight. It's an important one. So we're going to get into things very quickly here. In fact, I'm setting myself a 2-minute timer. So we got to keep it moving tonight as we have a lot to get through. And then we have a live stream after for the Ultimate Review Packet, folks. So just a quick reminder about super thanks or donations. I'm going to try to do my best to do shout outs for teachers or students or whoever comes up in between the breaks in between units. So those will kind of go off to a separate side. And then all those proceeds are going to Buck Creek, the Friends of Buck Creek Watershed, which is a place that my students are going to go do some stream cleanup and where you'll see some videos come up on the channel in the coming weeks as we head out into Buck Creek and do some cleanup. All right. A couple last minute pieces of advice here before we really transition into the content. Remember that if you're not sure what to study tonight, you're worried about this exam, you think you haven't covered enough content, you didn't get through everything in class, I would make sure to do Unit 9 and Unit 5. They're a big chunk of the exam, 15 to 20%, 10 to 15%, and Unit 5 keeps appearing in FRQs year after year after year. So students always ask, what are your FRQ predictions? And last year I made a TikTok that was like, I predict Unit 5 will be on the exam. And sure enough, Unit 5 was on the FRQ section of the exam, as it always is, year after year after year. It just lends itself really well to experiments. It lends itself really well to land use questions, to maps. So study Unit 5, study Unit 9. Those are big, important units to study. And then the math. If you know you still struggle with percent change, working with percentages, and unit conversion, there's a 20-minute math review video. You can get better at the math in 1 to 2 hours of practice time, and it's 6 points on the FRQ, and it's a couple points on the MCQ. So it's 11 to 13% of the exam where you don't even have to draw from your APES knowledge. So you can totally do this still. These are the most important things to do tonight if you're like way underprepared. All right, that was 2 minutes. Not bad. Okay, we're going to get right into it here. But before we do, just 2 important shout outs. One is Zoe from TikTok. Made it all the way through the Ultimate Review Packet. Made a great Phoebe Bridgers backed little TikTok, lamenting or making a tribute to the end of all 9 units of APES. I love Phoebe Bridgers. And so that was a great TikTok. Well done, Zoe. Good luck on the exam, of course. And then Mr. Smith from Hunting Valley, Ohio. Go Preppers. That's the school he teaches at. Mr. Smith is awesome. He has extensive geology knowledge, and he's actually going to show me around the geology of Ohio in near the Cleveland area after the APES reading. So I'm going to go grade exams in Cleveland with a bunch of teachers, and then I'm going to hang out with Mr. Smith after, and he's going to show me geology. And I'm really excited because I am not much of a geology expert. That's one of my weak points of my environmental science knowledge. So I'm really looking forward to this. Mr. Smith is a great teacher. And so are his scholars at in Hunting Valley, Ohio. Okay, we're going to keep it moving here with land use. So clear cutting. One other logistical thing. We have 2 moderators tonight. We have Kyra and we have Reed. We also have to have a LaCroix. And so they can help you out by pointing you towards links. The link tree is down in the video description below. That's going to have like all your APES links. And then the slides you're seeing on screen are also down in the video description below. So check those out. Okay, let's talk about clear cutting. When you clear cut, you cut all the trees down in an area. You lose your soil because the roots are no longer there to stabilize it and the soil washes away. That phrasing is really important. Stabilizing roots are a really descriptive way to explain why trees anchor soil down. So you lose the trees, the soil now erodes into the river, and this does a couple things. It takes nutrients out of the soil, but it also puts them into the river. And it puts soil in the river, or sediment, so the river is really dark in color now, and it absorbs more sunlight, so it's hotter. The sediments also are just warmer than the water to begin with because land heats up easier than water, and so the sediments take heat into the water. So the long and short of it is when you clear cut, you lose topsoil, you get muddy, turbid streams that are warmer, that hold less dissolved oxygen. And you can also have flooding and landslides. All right, now we're talking about agricultural techniques. Agriculture comes up on the Unit 5 section of the exam over and over and over again. It's something we need to talk about. So synthetic fertilizer is not to be confused with pesticides. Every year, students mix up fertilizer and pesticides. Remember, to make something fertile is to make it able to grow, to reproduce. And so synthetic fertilizers are going to be chemicals that humans can produce by burning fossil fuels. That's key. Then we're going to put those fertilizers, which contain nitrogen and phosphorus, we're going to put them on our agricultural fields, and that's going to increase crop yield per acre. So very good if you want a lot of food, right? They're a wonderful thing for society. But when we use them, we emit fossil fuels to make them. We don't emit fossil fuels. We burn fossil fuels, which emit greenhouse gases to make them. And we also have eutrophication. So these excess nitrates or phosphates that are in the soil from the fertilizer, they wash off with the rain, they go into a body of water, and we have an algae bloom on the surface. Now we're going to the steps of eutrophication in depth in Unit 8, so I'm not going to go into the steps in depth, but if you're looking for one concept that is most likely to show up on the exam, eutrophication, runoff, fertilizer, it's high on the list. I don't know if it's like top 3, but it's something I'm going over with my students in our final hour of prepping tomorrow. We're going to look at like climate change. We're going to look at the greenhouse effect, and we're going to look at biodiversity. Those are the big 3. And then from there, we'll probably go into like agriculture and eutrophication. All right, irrigation, active watering, bringing water often from the ground to your crops so that you can, again, increase yield per acre. This phrase is important. You don't want to just say more plants. You're growing more food in the same amount of area, increasing the yield, which is food per acre. You can also now grow plants in places you couldn't before. The problem is you can get soil salinization, where a little bit of the salt that naturally occurs in groundwater gets left on the soil. So the water kind of drains through or evaporates, and then the salt, which can evaporate, is left behind on the surface. So we can have soil salinization, and we can also even overwater roots. So roots need oxygen. They can essentially drown if there's too much water just pooling up on top of the surface. So irrigation is a great agricultural concept to understand. Drip irrigation is a good solution. Instead of spray or flood, we can do drip irrigation, and that's going to just deliver water much more slowly so that there's less salinization because you're getting less evaporation loss and just less water to begin with to get the same amount to your plants, or to get an adequate amount to your plants. All right. Caught a decent comment we're throwing on the screen here. Oh, look at that. Brunson. We got Jalen Brunson when I got my Maggie Rogers t-shirt on. I'm a Pistons fan, so I'm a little frustrated with Mr. Brunson after eliminating us in 6 games. He's great though, very clutch. He's been fun to watch. So we got the Brunson burner account saying, but drip irrigation is expensive and high maintenance. Very good. And the reason I really wanted to put this on screen is not just the Brunson burner account, I didn't even see that, is the fact that you often will have to propose a solution. So maybe the solution is to soil salinization and the solution is drip irrigation. And then you have to give a drawback or an unintended consequence of that solution. So drip irrigation will be more expensive. Okay. We can't turn this into too much of a basketball thing, but I'm a huge NBA fan. I'm going to be watching the highlights tomorrow morning. I think the Celtics are taking this one tonight. Definite. I know I got a Knicks shirt on, but Celtics are too good. Okay, let's look at environmental impacts of mining. So when you mine for ore, which is kind of the valuable metal that you're looking for, the valuable mineral that you're looking for, you're going to go into the side of a mountain, and that's going to have some consequences here. The one that's highly technical is acid mine drainage. Now, I wouldn't freak out about remembering the exact chemical formula here, that it's sulfuric acid, that it mixes with a rock called pyrite that contains that sulfur, and you don't have to get deep into the geology. Mr. Smith would explain the geology much better than I would, but the nice thing is you don't have to get super in-depth with the geology on the exam. You should know that acid mine drainage can happen, and now we can have pH outside the range of tolerance of aquatic organisms. So you're going to see some organisms dying there in the diagram. You could have toxic metals being more soluble. So mercury and aluminum in a water source, they become more soluble or more easily dissolved into the water at those lower pHs. So the acidification from the acid mine drainage, it doesn't have to kill the fish themselves. It could make a toxic metal more soluble, and that toxic metal is actually going to would be what's lethal. We also have, of course, methane release. So mine shafts are often going to continue to release methane. You know, there's all sorts of hydrocarbons that are mixed up when you're mining for a fossil fuel. So that's going to come out. You have the obvious ones too, like topsoil erosion, habitat loss. When you do mountaintop removal, you kind of blow up the top of the mountain with dynamite. So you're obviously going to lose habitat there. You're going to have rubble and, you know, what's called overburden. Overburden is a fancy name for all the soil and vegetation stuff above the ore deposit. That's going to flood down into the valley often. It's going to bury streams or make them really turbid. It's going to destroy habitat. And of course, it's going to erode soil. So you have all sorts of issues with mining in addition to particulates. The air is going to be filled with much higher levels of particulates when you're exploding a mountain. That's just what happens, right? Okay, so we're going to keep moving on to environmental consequences of urban runoff. Runoff is another huge concept. Like runoff definitely has a high likelihood of showing up on your exam in some way, shape, or form. It has really worked its way into FRQs over the past few years. Runoff just keeps showing up, whether it's on an experiment, whether it's in a map, whether it's like propose a solution to urban runoff. So urban runoff is a prime FRQ topic. Okay, let's talk about it. One thing you want to do, and it's why I have this upper right-hand diagram on the screen, is you want to be able to talk about impermeable surfaces in urban areas being a reason that runoff increases, right? So the rain falls on the impermeable surface and it runs off because it can't penetrate and it can't recharge the groundwater underneath the impermeable surface, in this case, you know, concrete or asphalt. So what it does though is it picks up everything else that's on the surface of the impermeable surface and it washes it into a storm drain. And as you can see in the lower diagram, storm drains then empty into a body of water, and then they empty into a larger body of water, in this case, the Chesapeake Bay. So the Chesapeake Bay, organisms that live there, crabs, which are a vital source of income for many people there, they may die off. So this is a great example also of human actions disturbing an ecosystem service. So you might have been someone who fished crabs your whole life. Do you fish a crab or do you crab a crab? You caught crabs. You put your crab nets down and you haul them up. And now there's way fewer crabs and you are either without a job, your profits are suffering, your revenues go down. And that's because of pollutants from impermeable areas that end up in the Chesapeake Bay. Examples are salt, sediment, fertilizer, pesticide. You can have oil and gasoline from cars. You can have antifreeze. Don't forget about sediment as a pollution, as a pollutant. A lot of times students forget that just sediment, just grit, tiny rocks, little bits of soil, sand from construction sites, from just vehicles picking them up and moving them onto the road. Particulates, sediment, they are a form of pollution in the water themselves. They make it more turbid. They can potentially get in aquatic organisms' gills if it's a heavy enough sediment load. And so not something you want in the water. It's a pollutant to try to remember. All right. Ooh, this is a great comment. This matters. Nice Kirby. Nice Kirby, whatever you want to call it, profile pic. So yeah, BOD drives DO, right? So when you have organisms demanding oxygen, biological oxygen demand or biochemical oxygen demand, when you have organisms that are demanding the oxygen, now the DO goes down, right? So when we have manure or sewage in a body of water, the microbes start digesting it all, breaking all down. That's how microbes eat. They just kind of amoeba around it. They break down the sewage, and that causes BOD to spike, and then DO drops. The DO goes down. because it's being demanded. And the order matters, right? The BOD drives the DO down. Just think of supply and demand. Well, that one's a little bit trickier. I'll leave the macroeconomics to Mr. Clifford because that's not exactly how it works. But when you have dissolved oxygen, which mostly gets just produced by plants in the water, they can't exactly ramp up their supply in a in a macroeconomic sense. But you get the idea. The biochemical oxygen demand uses up the dissolved oxygen. That's the reason it goes lower. A very good comment that I want to highlight. Very quickly, oh, here we go. Someone read my mind. Someone saw right where we were going. Solution to permeable pavement. Very good. And I like this cross view of the permeable pavement because it shows how it actually infiltrates into the pore space in the permeable pavement, kind of trickles down. Again, I'm using this imagery here to try to illustrate because I don't have a whiteboard that I can draw on. With my students, I'm always trying to kind of draw on the board and illustrate it. But you get this water that's just going to move through the permeable pavement and recharge the groundwater below. So it's also going to decrease flooding likelihood, which is an awesome benefit. We have rain gardens too. Rain gardens provide a double benefit of allowing that water to flow into the soil and then the roots use it, and it can also recharge the groundwater. But they're going to be habitat for pollinators, especially if you make them native plant rain gardens. They create a sense of space, so they add aesthetic value, aesthetic beauty to the city. They can even be considered like a cultural ecosystem service if they're really extensive rain gardens that people want to be by. And so just another way to get two benefits out of one. Okay. Pause for a quick minute here. We'll see. I think we can only take about 1 minute here. So I'll pause for a minute while people try to take a stab at one of these two practice FRQs where you could try applying something we just learned. So take a look at these practice FRQs, give one a shot. All right, we got one here. Eddie Bean, let's see how you did. Water that runs through crops or croplands near the streams and river containing nitrates and phosphates runs into the Gulf. Okay, good. So we're tracing the flow. You've kind of illustrated how this is getting there. Now have you connected it to the dead zone? This leads to excessive algae growth, and a drop in dissolved oxygen. The only thing you might be missing, Eddie Bean, do we need to have the decomposition? Let's see. Fertilizer used on croplands is washed into streams and rivers in the watershed, and it feeds the growth of algae once it reaches the Gulf. So well done, Eddie Bean. You nailed it. I would give you this point. That top bullet point on the rubric, you would have earned that, which is great. The thing you left off, Eddie, which students usually forget, is it's the decomposition of those dead algae that then drop the dissolved oxygen level. Because, as we just went over, BOD goes up, the algae are dead, and the microbes in the water demand oxygen to aerobically break down the algae. And so BOD shoots up, DO shoots down. All right, IPM, don't forget about IPM. So we know pesticides are these, synthetic chemicals that we create to kill pests. That's helpful for us because we have a more stable food supply. They can also control disease vectors like mosquitoes. But those pesticides have unintended consequences. They kill non-target insects as well in the water. And now the fish that relied on those macroinvertebrates might not have their food source. So instead, we can use something called IPM, which doesn't mean no pesticides. IPM just means we're going to try to rely on a variety of methods and minimize the pesticide use. So we're going to use things like maybe a biocontrol, aka a natural predator. Ladybugs eat aphids. Spiders can sometimes control pests. Certain bird species could control pests. So you either bring in a natural predator or just build their habitat, plant trees that attract a certain type of spider or bird. They control the pest for you without a pesticide. You can rotate your crops. If you plant a different crop in the same field year after year after year, rather than the corn beetle, let's say larvae hatching each year and being ready for corn, they might have beets one year, they might have peas another year, they might have radishes. And so you don't allow the establishment of this generational pest population feasting on the one crop that they are, optimized or evolved to thrive on. Intercropping is another method where you can intersperse crops with different crops. You can do this for erosion control. You can do this for like a symbiotic, or I guess synergistic, the word I'm looking for, kind of effect. Think of like the Three Sisters method of agriculture that, Robin Wall Kimmerer documents really well in Braiding Sweetgrass. I'm sure many other folks have documented it, but you have the peas and the beans and, oh my gosh, the corn in the middle for them to climb. And they complement each other in terms of the nutrients they take out of the soil. You have the peas or the beans as the nitrogen fixers. Corn's really nitrogen heavy. The corn gives kind of a trellis for the peas to climb. The squash has these kind of spiny leaves that provide some protection around the base. And so you're doing polyculture too, where you have numerous different species kind of all in one field. So this is similar to intercropping. Okay. Some more sustainable ag techniques you should be familiar with. Windbreaks are what they sound like. Very simple. You just plant trees or large shrubs or bushes around your ag fields. Now, when the wind comes, it has to kind of move up and over. It's not going to be able to just blow right through the trees at full speed. That's going to reduce wind-driven soil erosion. The nice thing is you could also do fruit trees, and now you're maximizing your profits if you're a farmer, because you can harvest apples and sell them. Or eat them yourself, and you have a provisioning ecosystem service. Then we've got no-till, and this diagram helps you kind of visualize how when you don't till, you leave that organic matter in the soil after you harvest. So you still take the corn, the ears off of the stalks of corn, but you leave the physical plant matter in the ground. So the roots anchor the soil. The residue of the plant, like the part that you don't want to take to the store to sell, but that was still part of the plant, it dies and it falls down on the soil. You might even mulch it into what we call green manure and leave it on the soil. And what that's going to do is return nutrients to the soil and stabilize the soil. And so no-till means you don't chop it up mechanically and mix it all up, which makes it more likely to blow away in the wind. Now, tilling can be useful because tilling can break up weeds. Tilling can also make it easier to plant your seeds and easier for them to get their roots into the soil. So there are reasons to till, but no-till on the APES exam is always pretty much one of the prime solutions to soil erosion. And then the strip cropping is really just intercropping. Again, you can alternate rows of plants. It could be, again, for erosion control. It could be just for like a legume to kind of supplement and add nitrogen back to soil. There's a lot of reasons to strip crop or intercrop. All right, and then crop rotation. I mentioned crop rotation earlier as a way to prevent pests. Now, you can also do crop rotation with a nitrogen fixer. At this point, we've talked a lot about nitrogen fixation, so I don't want to belabor the point too much, but to highlight and underscore that point one more time, peas and beans, organisms in the legume family, they have these mutualistic bacteria, rhizobacteria. You don't have to memorize the name, but rhizo just means soil. Those bacteria live in the root nodules and they fix nitrogen. So if you have a really demanding crop like corn, which tends to take a lot of nitrogen out of the soil, you grow legumes in the soil the next season, and you're going to return nitrogen to the soil. And again, you can leave some of the crop residue in the soil as well as kind of green manure. All right, I do want to put this comment on the screen. So, someone who's a Mr. Sin fan, yeah, Mr. Sin is great. He's also someone that I work with at the Ultimate Review Packet, great human geo teacher. So on the describe FRQs, you get points with as little as 3 sentences. Yeah, on the describe FRQs for APES, you can get it with 1 sentence. So this is just like a PSA. I'm going to do a little bit more last minute FRQ tips tomorrow. But you can get every point on the APES exam with as few as 1 sentence or with as little as 1 sentence. There's nothing magic about explain or describe prompts that says you mean many sentences. Often you'll need two. You can obviously write one run-on sentence, but often it's helpful to have two because you give your first layer of detail on describe and your second layer that connects you back to the prompt. Or in explain, your first layer and then you're kind of step-by-step connecting your first layer to the prompt. So it's probably helpful to aim for 2 to 3 sentences, but I would not go beyond 3 sentences on almost any FRQ. You just do not need to write that much. All right. All right, here's a good practice FRQ. Propose one reasonable method. Do another 1-minute timer so we stay on pace. One reasonable method other than crop rotation to reduce the use of pesticides and agricultural practices while still maintaining a high yield. Now, in propose a solution, it's almost like in between identify and describe. You're mostly stating it. It doesn't hurt to add a little bit of detail so that you're not way too brief. So like, for example, people are just saying intercropping. I would add a little bit of a description of intercropping on a proposed solution, or a little bit more detail about how to intercrop, or why it's related to decreasing pesticides. All right, I'm trying to look for, here's an example. I think this answer would probably earn the point. It's so brief, but biocontrol introduces a natural predator to manage pests. So we look at the answer key. We have use integrated pest management to control the insect crop pest. I think this answer here that's on screen counts as part of integrated pest management. It's like a major method of integrated pest management. Or use a method of pest control that employs a variety of biological, physical, and chemical methods. This would be one of those biological methods. So this is a great example of an answer that's not like word for word on the scoring guide. Now, if I were actually doing this question in Cincinnati or Cleveland at the real reading, I would need some clarification to make sure we could accept this. But I think this should work. Let's just see if we have anything a little more. Yeah, we've got a lot of biocontrol. And I think that should work. All right. Yeah, really good answers to this FRQ. Okay. On we go. Okay, Unit 5 must know vocab. These are things that I would really try to make sure I understand if you want to do some Unit 5 review. So check out those must know vocab terms, and then most likely FRQ topics. There's a lot of most likely FRQ topics in Unit 5 because Unit 5 keeps coming up on the exam over and over and over again. And so clear cutting is an important one. Green revolution and impacts of agriculture. That's like maybe the most likely to be on the FRQ section. You get mining, sustainable ag, reducing urban runoff. The nice thing about Unit 5 is it has so many environmental solutions, and you know you're going to have to give a solution to an environmental problem on FRQ number 2. So that's why I really recommend Unit 5 is a great thing to review. All right, just peeking at the chat. I love that you guys answer each other's questions. This is great. This is what I love about APES scholars. The brain rot has been very minimal, if at all, tonight, which is great. Last year's live got way too much brain rot. So you guys have done an excellent job of what I tell my students: narrow your attentional spotlight, right? Lock in is brain rot. It's total brain rot. The kids that say they're locked in, they're never locked in. And the people that are locked in, they don't tell you they're locked in. They just take care of their work, right? So the phrase I've told my students to replace it with is narrow your attentional spotlight. It's very scientific. It's how cognitive scientists talk about attention. Is we have a spotlight and we manipulate or we change where our spotlight of attention is. And when you can narrow it and hone it in on something and put other distractions like your phone or Roblox or whatever to the side, you can focus. Okay, teeny little break for me. A nice album recommendation for you guys. Absolutely love the record, Boy Genius. Only wish they were making more music. Phoebe Bridgers, one of my favorites. She'll make an appearance again. She's awesome on the Boy Genius record here. So highly recommend it if you're looking for some study music. All right. Oh boy, there is. There's a great comment that I can't put on the screen. Oh boy, you guys are funny. Okay. Good question from Beefy Bertha. Interesting screen name. Yes, you can store formulas in your calculator. It specifically says in the Proctor handbook, and I talked to our AP coordinator in Proctor today at school to verify. I can actually cross this off my to-do list because someone asked yesterday. You can store a formula in your TI 83 or 84 calculator. Google how to store formulas in your calculator. It'll pop right up on YouTube, and you can store formulas. I have a slide in tomorrow morning's live stream. It's also in last year's FRQ and math live stream. So you can check that out. There's really only 4 APES formulas you could potentially need to store. Percent change, new minus old over old times 100. NPP equals GPP minus respiration loss. The rule of 70, which is 70 over R, or 70 over the growth rate equals the doubling time. And then growth rate is CBR minus CDR divided by 10. Those are about the only 4, again, quote unquote, formulas. I don't think it's even really worth it. Personally, I would just spend like 5 minutes memorizing those before I go to the exam and then like write them down on my scratch paper. So another tip I love to give my students, if you're nervous about something, memorize it right before the exam. Like sit outside the exam room with your notes and just say it like 10 times in your head. Make a little mnemonic device for it. You know, like, please excuse my dear Aunt Sally, PEMDAS, order of operations. Make a little mnemonic for it. And then as soon as you get to the exam and the proctor gives you your scratch paper, so everybody gets a sheet of scratch paper, write stuff down on your scratch paper that you memorize, and then it's out of your head and you don't have to stress about remembering it. So you can store stuff here and then put it down on paper. It's a great exam tip. Okay, good question from Beefy Bertha. All right, we have Mr. Smedes fan shouting out Mrs. Bonewald. So Mrs. Bonewald, your scholars appreciate you. We have Mango Bubbles shouting out the APES GOAT, Miss Stearns. Miss Stearns, I hope I'm saying that right. Miss Stearns. Your APES scholars appreciate you. They consider you the greatest of all time. Okay, I'm not going to put all of these on the screen. Some of these are kind of silly. We have a student who wants to shout out Mr. Franzmeyer's class. Okay. I don't know about your friend's name. I don't know that I'm going to say that one live. Some of you may be abusing this feature. Shout out to Mr. Johansmeyer. Johansmeyer, that's a cool name. We have another teacher shout out, Mr. Reinert. Mr. Reinert, your APES scholars appreciate you, especially Anthony. Well done. This, I'm wondering if someone's trolling, if we actually have an 8th grade APES class. My understanding was that middle schoolers were not allowed to take AP exams. I'm not sure if that's the case. So we may have a troll among our hands, or we may have an 8th grade APES class, which is very impressive. Okay, we have a shout out for Mr. Hone, the best teacher in Massachusetts. He got some shout outs yesterday, so kids really love him. Beefy Bertha with another question about the math formula. It's the same question though. One thing just to remind everybody, these super thanks are all going to the Buck Creek, Friends of Buck Creek Watershed. In fact, we'll have someone from Buck Creek on the channel eventually to like receive the donation. But I just want people to know this is I'm not taking time out of the live stream to just line my pockets with super thanks. So it's going to a good cause. Okay, we do have to get through these. All right, we're gonna have to go quick. I might save some of these for the next break so that we do get more reviewing in. Okay, someone's fried. I'm sorry. Oh boy, I'm not. Okay. I got to screen these a little bit more. Somebody explain GERT. I keep seeing it. I heard it's like something, you do something smart but dangerous. Something like that. Okay. We have a shout out to the GOAT, Osman. So Mr. and Miss Osman. Okay, I'm going to not get this name pronounced right, but Mr. Ashokumar, I hope I'm saying that right. Shout out to Mr. Ashokumar. All right, we're going to do 3 more, and then we got to move on. And I'll circle back on our next break. Miss Hansa, APES teacher at Lincoln. All right, Kelsey gives you a shout out. 2 more, and then we're taking a break, and we'll pick back up on somebody else. All right, Dr. Brines and his Mountain Dew from Fayette County High School. He's a big Mountain Dew drinker. Hey, whatever it takes to get you through APES. It's a demanding subject. All right, last one for this break, which is Mr. Hone again. People are a big fan of Mr. Hone. So we're going to pick up with, I'll write down the comment to pick up on when we resume. Okay, again, if you did a super chat, it will get thanked eventually. Let's get our banner. People were not happy last night with the banners being out of whack, so let's keep them happy. All right, crude oil, petroleum. This is a concept students I feel often have a little confusion about. Okay, so let's talk about where it comes from first, which is, broken down, decaying organic matter, often in a marine setting, or what used to be a marine setting. We're talking about shelled organisms, crustaceans, and they're going to be compressed, heat, pressure, time. That's basically the fossil fuel recipe. And they get condensed into a liquid hydrocarbon, which we call crude oil or petroleum. Okay, we have to extract it though, and you can just pump it out of the ground under pressure if it's a high quality petroleum. But if it's a low quality petroleum like tar sands, which is basically just this sticky, dense, viscous combination of petroleum, clay, sand, and water, so it's kind of petroleum mixed with impurities, we have to use a bunch of steam to get it out of the ground. So we call that steam reforming. And that steam is going to loosen the petroleum so it kind of flows more easily and now can be extracted. This is really energy intensive. You need to spend a lot of water to get it out. You need to heat the water into steam. And so it takes a lot more energy to get at this energy source here. Okay, this is a slide you might want to take a picture of. The reason is because if you can remember heat turbine or heat steam turbine generator, you're remembering almost all the forms of electricity generation. So if we can get heat, we can turn water into steam. That steam can spin a turbine, and that turbine can power an electromagnetic generator. So there's magnets inside the generator, copper or other type of conductive metal in between. They spin really fast and they generate an electrical current. You don't really need to know the last part. On every APES FRQ, it's been sufficient to say that the spinning the spinning turbine powers the generator to produce an electrical current or to produce electricity. But what I want you guys to focus on is the fuel source. It can be anything really that can generate heat. We could burn coal or natural gas. That's most likely. You can technically burn oil in an electric generator. It's just not very common. Oil is much better for transportation. You can burn wood pellets. You can burn trash. You can incinerate waste. And you can even use a nuclear reactor to heat water via a fission reaction. And so even if we replace the boiler in this diagram, nuclear is going to work largely the same way. So these steps you should know. Again, heat, water into steam, steam turns the turbine, turbine powers the generator, and you have electricity. Seen a couple comments about these slides. They're down in the video description, top link. Okay, nuclear confuses some people. It is non-renewable. The uranium that we use, occasionally plutonium, mostly uranium, the uranium that we use is limited. It's finite. It's going to run out. And so it can't regenerate at the rate that we use nuclear power. So it's a limited resource. It's closer to the renewables, though, in terms of its environmental impacts, meaning no air pollutants produced when you generate electricity. So you do have to mine for uranium. So it has some of those negative impacts of mining that we reviewed earlier. Any negative impact of mining is going to come with mining for uranium. But it's a pretty big benefit that it produces huge amounts of power per unit of area. It's massively power producing and energy efficient. And from that standpoint, and doesn't release any air pollutants or any greenhouse gases. So it's a really powerful form of non-polluting energy, but it's not renewable. So we have to keep those things straight. A couple of vocab terms you might want to know are spent fuel rods. These are the uranium fuel rods when they are no longer viable. They can't produce enough electricity via their fission reaction. And so we've got to store them in containers for hundreds of thousands of years because they're still radioactive. Same thing with the mine tailings. Sometimes those mine tailings might have radioactive elements. So uranium mine tailings are a little bit harder to work with. It's going to use a lot of water to cool the reactor and to turn into steam to spin the turbine. And then that water has to get discharged. And if it's not cooled adequately in a cooling tower, it can cause thermal pollution. So the dissolved oxygen level can decrease. The respiration rate of organisms increases, and aquatic organisms can actually suffocate. It's weird to think about a fish suffocating, but they run out of oxygen because the water is heating up too fast, and their respiration rate is increasing by the heat. So there's some big issues with nuclear. All right, hydroelectric dams. Remember, they're not just for producing electricity by spinning the turbine with the water coming from the reservoir. They create jobs. You can do tourism on them. They can increase property values if you build, houses around them because they have these recreational opportunities. You can divert the water for agriculture. So actually in the US, very few dams are hydroelectric. The vast majority are like recreation or scenic purposes. And then the second big purpose is just like controlling where rivers flood. So, large rivers typically have a floodplain that's going to fill up with water in the rainy season or when you get the snow melt from the mountains. And you can limit that with a dam. This is just a picture that kind of illustrates that like hydrologic cycle here where we have water from the mountains melting, flowing down, feeding these strong streams that build into rivers. And then we build the hydroelectric plant kind of still in the mountains, but downhill somewhat from the snow melt that's happening. And that can be really effective to produce a lot of electricity because not only do you have the slope of the water coming down, but you have a huge, feedstock that's coming in or all of that snow that's melting. All right. Looks like I froze in an unfortunate position for a second. The other thing I like about this is it highlights how that floodplain zone can be built in and have agriculture done on it now because of that ability to prevent it from always flooding. Okay, I want to clarify something here. Where did it go? This is a good question. A dam is not an ecosystem service because we build it. And so dams are human constructions. An ecosystem service is something that like an intact ecosystem does for us. So a wetland provides ecosystem services like taking in stormwater to make floods not as bad, or providing habitat for fish that we might catch and eat. So a dam is not an ecosystem service because we build it ourselves. It doesn't come from an ecosystem. Okay, let's do 1 minute to practice an FRQ here. This is a good one. While people are working on this answer, it's a good question from Haley. If you do no setup, you're definitely not going to get one of the 2 points. I haven't graded a math question for a while, and so I can't remember. I think you still get the point if you have the correct answer, but no setup. I think you would just get 1 out of 2. If you set it up in an unexpected way, that's fine. As long as it's a logical way to set it up. It doesn't even have to be like the best way or the second or third best way. But if it makes some degree of sense to the reader looking at it, oh, I can sort of see how the student arrived at this answer, you'll get the point. Okay, let's see if we've got an answer to this question. Oh, I like this one. I think this would probably work. Coupling allows solar or wind to generate power during the day or when windy, while hydro compensates during low sun or wind, ensuring a continuous and stable electricity supply. This last phrase is nice. It's really demonstrating that the student's trying to connect back to the answer. So this answer key says solar and wind are both intermittent. So coupling solar and wind. So this student's getting at the intermittency by saying during the day or when windy, while hydro compensates during low wind or sun, which on the FRQ answer key would substitute for that phrase when the solar or wind power is unable or not sufficient. The only way to really strengthen this question is to add in that idea of intermittency. Intermittency is a great vocab term to know. The idea that an energy source cannot produce 24/7, 365 continuous power. So that would have strengthened it a little bit, but I think you'd get this point. I think your language is equivalent to what they have here. Because you've indicated, well, I don't know, you'd be on the fence. It'd be a stronger answer, and this is where explains try to push for that second sentence. A stronger answer would make like really explicit mentioning of solar and wind being unavailable at night for solar or when the wind is not blowing fast enough for wind. You've kind of done that with hydro compensating during low sun or wind. I would lean towards giving you this point. Again, though, I'd have to talk to the table lead or someone at my table on that one. All right, large scale versus small scale energy conservation. So this is a prime topic for showing up in the exam because we have questions that are about proposed solutions. So these are all great solutions. You know, energy efficient appliances using producing the same amount of heat or cold with less energy is a great thing. When we look at the federal level or like a large scale, you have the CAFE fuel efficiency standards. You have a tax credit or a subsidy for an electric vehicle or electric charging stations. You can subsidize or build more public transportation routes. These are all really good solutions to have in your bag. Now, remember, you don't just want to say, take the bus as your solution. You want to say like cities can invest in more public bus lines, or the government can offer a tax subsidy for electric vehicles. You don't want to just say on your FRQ, what's the solution for, in fact, we have one coming up here. Make a claim, a realistic government action to improve air quality by reducing consumption of oil. You don't want to just say like, get a Tesla. You want to link this to a government action. So we're not going to put answers on the screen here because we want to keep things moving, but use tax incentive to encourage sales of hybrid or electric vehicles. Invest in renewable energy. An investment's a specific thing. It is money from the federal government being put towards a project. So look at these kind of like power verbs, I would call them. Increasing fuel economy standards, investing in renewable energy, using tax incentives, subsidizing projects. That means the government pays part of the cost. They're like, hey, city of Grand Rapids, where I live, if you build better bus lines and your buses run on natural gas, or even better, methane from our local wastewater treatment plant, which is actually the case here, we will pay for part of your bus fleet because we believe in lowering carbon emissions and making air quality better for residents, right? So subsidizing means the government pays for part of the project. So you really want to have these verbs down for what governments actually do. And you don't just want to say, drive an electric car or whatever. All right. I did just happen to glance over and catch this one. A fellow Grand Rapidian. Very cool. Love to see a fellow Grand Rapidian in the chat. That is fun. Okay. On we go. Some must-know vocab terms here on the screen. Don't panic if there's one or two of these you're not sure about. But these are what I think if you're going to review Unit 6, I would focus on trying to make sure I brush up on these terms. I didn't know it's really hard to pull the most likely FRQ topics out of Unit 6 because they have a whole bunch of renewable energy sources that are all kind of like more or less equally likely to be on the exam. Fossil fuels, though, is just very likely to show up on the FRQ section in some way, shape, or form. It almost always does. And then energy conservation. I put on there because there's just so many solutions in energy conservation that, you know, it's likely to come up in one of your proposed solutions. All right. This album, wow. Discovered this one on what's his name? Anthony Fantano, the music reviewer, the busiest music nerd on the internet. He had it in one of his roundups. I gave it a listen. Listen to nothing else for like a month. Beautiful album. Highly recommend Jess Williamson. Can't recommend her enough. So check her out if you want some nice Americana style music. Okay, back to our shout outs. Where did I leave off? Okay. Shout out to Dr. Hobbs. He's the #1 APES class in New Hampshire. Very cool. Flame emoji. Dr. Hobbs, your students appreciate you. We have a shout out to Miss Sprague. I hope I'm saying that right. Sprague from Austin High. Yeah. Exclamation point emoji. Very good. Oh, this is fun. Someone from last year got a 5. Way to think like a mountain and write like a scholar. Well done. Thanks for coming back. We have Mr. Howard and his new baby. Oh, Mr. Howard, congratulations. We have a new dad, or maybe not a new dad, but a dad of a new baby who's an APES teacher. I hope your scholars do great tomorrow. All right. Big Smedes, I'm so cooked. I'm sorry to hear that. Good luck. You smelled Smedes wrong, so that's not going to be an APES exam, though. Mrs. Turner is amazing. It sounds like she's worked hard to get you ready. You might not be as cooked as you think. Study Unit 9, study Unit 5. Good luck. All right, we have a shout out to Miss Julian from BRHS in New Jersey. Very cool. New Jersey is a great state. I know some APES folks out there. Chris Kling, or Mr. Kling, I should say, is a great APES teacher from New Jersey. All right, shout out my queen, Coghill. We love your slideshow. So your students really appreciate your slideshow, Queen Coghill. Shout out to Miss Beckman, Milo, and Ryan. Wonderful. Miss Beckman, sounds like your students really appreciate you. We have a shout out to Miss Davis. She always recommends the channel, it sounds like. Glad you find the videos helpful. As Paul Anderson says, the true GOAT of science education on YouTube at the end of every video, and I hope that was helpful. He's the guy with the black background, the AP Bio guy. Great. On everyone else's soul, I'm getting a 5. All right, Keegan Murray called your shot. You'll have to come back on July 8th, Keegan. Come back to the channel and let us know if you got that 5. You put it on everyone else's soul. I assume you're supposed to put it on your own, but anyway. Shout out to Miss Rezka. All her students are super prepared and confident for the exam. So way to go, Miss Rezka. Students feel ready. All right, shout out Mrs. Schwing, the best APES teacher in New Jersey. We have another APES New Jersey teacher. Someone asking for a shout out for Miss Michael from Houston. Miss Michael, your scholars really appreciate you. All right. We're skipping a few of these, you guys, just because you make a donation to Buck Creek. Doesn't mean your weird message has to go on the screen. Okay. We have a couple more, and then we're going to go on to Unit 7. We have Miss McLaughlin. McLaughlin. You have to say that one fast. If I say that too long, I think about it. If I think about it too long, I say it wrong. Miss McLaughlin. Your students appreciate it, especially Michaela. Okay, let's do, how many more do we have? Oh my gosh. Wow. Okay. We're going to have to do a speed run of these at the end, but we gotta keep moving here. Okay. Where were we here? You know what? I might save some of these. I might turn off the super thanks and save some of these for tomorrow mornings as well. All right. We have Miss Z, the best apes ever. We have a shout out for Mr. Slusser. He loves to take his toes. Oh boy. Okay. I got to screen these better. I'm sorry, you guys. Dr. Horej, MIT. He is the GOAT. Awesome. We have Mrs. Tomlinson at Portland High. Very good. Okay. We have Mrs. Kessler in South Florida, a sustainable queen. Oh, awesome. A sustainable queen. We'd love to hear that. Let's see. This is a good question. And they donated to Buck Creek. So let's get their question answered. I would study 9 and 5. The reason is 5 keeps coming up on exams, FRQs in the past, and 9 has a bunch of environmental solutions, which also we know is going to appear on the exam. This is a good question too. There is a guide that I will add to my link tree. So Jams, if you check my link tree tonight in like an hour, math PDF. I wrote myself a note, so I'll do this later. There's a 2-pager that will explain exactly how to do this. So if you're curious, check out later. Okay, I'm not sure what currency this is. IDR. So someone maybe from abroad. Shout out to Mr. Bonino at JIS. Thank you for all your hard work and making apes an interesting course. So IDR, interesting. I don't recognize that currency, but very cool. We got 100,000 of whatever an IDR is. All right, we're going to do 3 more, and then we got to get back to content. Can you announce to the world? Oh boy, I truly didn't read that, and I probably wouldn't have put it on the screen if I would have. I am sorry to those students. I did not read that one fully, and I don't know that we need promposals happening in the APES review. Okay. Shout out to Miss Piccolo and Mr. Benson. And then last one for this break is a shout out to Mr. Gellner from Coatesville. He's in Pennsylvania. We've got a turtle and a coral reef. So we're going to try to pick up with Ethan when we come back. But again, these are getting a little out of control. I don't want us to not get any review in, right? We do need to do some review. We can't just do shout outs all day long. So let's get our ticker to unit 7. The good news is we're going to fly through units 7 and 8. In fact, no, we can do a little bit. But I need to do, let's see, 15 minutes for unit 9. We're going to do like 8 minutes for 7 and 8 combined. They're just not heavily featured on the exam usually. So we're going to go quick. Okay, on we go to unit 7. And the banner's changed. So the people that were asking for the banner, there it is. If you're looking to memorize a slide, this is not a bad one to revisit. So you might take a picture of this and try to remember this in the morning. You've got the Clean Air Act, which sets the 6 criteria pollutants. I'm not going to go over them all right now, but you want to know SOx and NOx, carbon monoxide, particulate matters, ozone, and lead. These are all pollutants you should know. If any of these you're looking at and thinking, I'm really not sure where they come from or what they do, again, take a picture of this slide, bookmark this point, do a screen capture or whatever on the Chromebook or whatever you're watching this on, and then check these out later. Video 7.1 also would go over this concept. The reason I want to move on quickly is because this takes a little more explaining. So photochemical smog is a little more technical of a concept that can use some explaining. So I always tell it in kind of a story form to my students to help them remember that NOx, or NO2 specifically, is a huge driver of photochemical smog. So people get up in the morning for the morning commute, their cars release a lot of NO2. That NO2 then gets broken down. So see the red squiggly line on the screen, that's going to break the NO2 into nitric oxide, NO, and then a free ozone, or excuse me, not an ozone yet, a free oxygen atom. That free oxygen combines with an O2, right? And O plus O2 is O3. So we form ozone from the free oxygen atom that popped off the NO2, and now it links up with the O2. That usually reverses itself at night, so that ozone builds up a little bit during the day and then breaks back down at night. When VOCs are added to the equation, which is volatile organic compounds, so hydrocarbons are a huge VOC source, gas stations, also some paints and adhesives can be volatile organic compounds as well. but they bind to the nitric oxide and they prevent the reversal of smog or of the ozone. And so you get smog formation because the ozone levels start to build up. So this mixture of nitric oxide, the VOx, and the ozone is what we call photochemical smog. Okay, we're just going to go over the answer for this one. We don't quite have enough time to do practice FRQs here. I really want to suspend the most time that we have left, like the majority of our time left, on Unit 9 because it has a lot of content and it's most likely to be on the exam. So we're going to move quickly. Why would summertime be increasing photochemical smog? So you don't just want to say more sun. Like that's part of it. But you want to be clear, and here's kind of your layers of detail. First layer, there is more sunlight, or there's brighter or more intense sunlight, or sunlight for longer parts of the day, more time in the day in the summer. So there's our first step that we've established. And the second step is then that nitrogen oxides or NOx, they react in sunlight. Now notice we don't even have to get into the breakdown of NO2 into a free oxygen and its combination with O2 to form ozone. Because the question is not describe how photochemical smog forms. It's describe how summertime weather can increase the frequency of smog. So your two layers of detail are connecting summer and smog, not walking you through all the steps of smog formation. So again, you want to answer the question you're asked, not make up your own question and answer that. And so you have to answer, why does summertime weather increase smog? Not just start going in depth into smog formation. All right. Those are some important terms to know, especially the criteria. Air pollutants, again, watch the 7.1 video if you're looking for something that will be useful tonight. That will be a good use of 5 to 10 minutes of your time. So I have that as a most likely FRQ topic. It's likely to come up on the exam in some way, shape, or form because pollutants are produced by so many different things, right? There's fossil fuel combustion, there's agriculture, there's power plants, there's cars, there's construction. There's so many ways that these pollutants can be produced. And so knowing them can help in all those variety of FRQ possibilities. Okay. No music recommendation would be complete without an absolute banger of an album. So throw on some Chapel if you've been living under a rock for the past 3 years and haven't already been listening. I was listening to Chapel, Pink Pony Club in like 2022, like right when it dropped. So it's been very exciting to see her meteoric rise. And if you're looking for something fun to do after the APES exam's done, go watch her interview with Nardwar. Great interview, great album. Okay, we're going to keep moving and we're going to do after Unit 8 with the banner changed, of course. We're going to do some shout outs then. Okay. I really did not look at the name on this. Michigan caught my eye in the chat. You guys are way too quick with the with the goofy YouTube names. But my favorite lake is Lake Michigan. It's the best. It gets warm enough to swim. On the other side is Wisconsin. I'm a big fan of Wisconsin. Yeah, I love Lake Michigan. It's a great lake. Okay. Cultural eutrophication. We've got to talk about eutrophication. So I said this earlier. I think everybody remembers with eutrophication. People remember that it's fertilizer that leads to this, right? Sometimes those students make the mistake of saying it's pesticides. And remember, pesticides kill things. They don't fertilize them or make them grow. So fertilizer is going to flow into the water, or a source of nutrients, which could also be organic waste. It could be from livestock. It could be sewage. So it's not purely fertilizer, but it's a nitrogen or phosphorus input. The algae bloom because they have excess nutrients now that used to be limiting their growth. They cover the surface of the water so they can block the sun. Then they die. And this is the critical part. The part on screen that everybody misses is that the bacteria use up the oxygen. They use up the oxygen, and now we have hypoxia, or a low oxygen dead zone. So there's low dissolved oxygen levels, and that's why organisms die. So I'm going to repeat this one more time because it is important. The step that people leave out is the bacteria using up the dissolved oxygen to do aerobic decomposition. You probably don't need to call it aerobic decomposition. You can just say the algae break down the organic matter. I'm sorry, the algae are the organic matter. The microbes or bacteria, decomposers, break down the organic matter and they use up the dissolved oxygen. That phrase there is key. Again, another video that is probably worth your time to rewatch tonight is 8.5. So 7.1, very worth your time. 8.5, very worth your time to review. FRQ example, how would we connect the dead zone in the Gulf of Mexico to increasing in the summer months? So this is going to be maybe a little bit different than you're expecting. One of the main answers is just that it's going to be hotter, okay? And so when it's warmer, the water just holds less dissolved oxygen. And so that's a fact that you want to try to remember. So we don't automatically have to go right to fertilizer. And the thing is, you can go to fertilizer on this question about why eutrophication is worse in the summer months, but you have to connect that to the growing season, right? In the northern hemisphere, in our summer, agriculture ramps up, production ramps up, so fertilizers are being applied more, and they're making it into the water more. All right, we're at 46 slides out of 60, and we have 23 minutes left. So I may skip ahead just a touch to keep us, well, I can just go really brief on a couple things. So range of tolerance is a phrase that keeps showing up on scoring guides. This is like if your mind blanks. I saw a few TikToks about this. They're like, what do I write if my mind blanks? If your mind blanks about a negative impact, conditions moving outside the range of tolerance of an organism is kind of a fancy way of saying like they can't survive anymore, right? But you want to ideally name the conditions, or the condition, I should say, that's outside of range of tolerance. So pH, temperature, salinity, sunlight, nutrient levels. You want to give the attribute of the ecosystem and then say it's outside the range of tolerance of this organism. That can be limited growth. That could lead to limited reproductive function, difficulty doing respiration. So you don't want to just jump right to death. Okay. Got to talk about mangroves quickly. So mangroves are going to be in tropical regions along the coastline. You don't just want to talk about mangroves as a solution to runoff. Like you can't just plot mangroves down in the Mississippi River. I've seen students write about that before. What you need to do is know where they are, which is in tropical regions along the coast. But you should know they provide all these ecosystem services. So they provide provisioning services by people being able to harvest their wood and burn it or build with it. They can also, though, be a breeding ground for a ton of fish and shellfish species that are caught commercially. So a lot of people get their livelihood from mangrove trees because of all of the organisms that live in their root structures underground. Or they don't live in the root structures, but they swim in between the roots that are down in the water. They may hatch down there. They may hide from predators down there. And then tourism. Shout out to Marcos, one of my students, Marcos from GRP. He went on a field trip, or not a field trip. He went on a vacation to Florida, and he toured some mangroves. He said they got up close and saw the mangroves, and so that's a recreation activity that he did, and it's an ecosystem service, a cultural ecosystem service. Mangroves do a whole bunch of other ecosystem services. They stabilize the coastline so it doesn't erode. They sequester carbon so we have less climate change. But they're very, very important species to know about. All right, so what are some other must-know Unit 8 vocab terms? You want to know these ones that you have on screen here, especially eutrophication, algal blooms, hypoxia. You want to know about mangroves. You want to know about a riparian buffer, which is that vegetation on the side of a stream or river body of water that's going to absorb pollutants that are running off and be taken into the roots of those plants if it's nutrients. Even some like contaminants can be kind of trapped by the plants themselves or the root structures so that they don't make it into the water source. Okay. Most likely FRQ topics. I threw eutrophication on here because it comes up often, not always, but it's very possible. And then I picked 8.2 and 8.4 because we know there's going to be a problem on FRQ number 2, like an environmental problem. And 8.4 and 8.2 both heavily deal with environmental problems. And so those environmental problems also have solutions, which are touched on in 8.2 and 8.4. So if you're looking for something to review in Unit 8, these are some topics that you could consider. Unit 8, though, as you can see on the ticker at the bottom, 7 to 10% of the exam, I wouldn't spend huge amounts of time on it, okay? All right, we got another break with probably my favorite album of all time. I think this is the best album for me so far in life. Frank Ocean, a legend. We're still waiting on that upcoming album, Frank. It's been about 9 years since you dropped your masterpiece. So yeah, we need some new Frank Ocean, but very peaceful music. If you need something to like go on a long bike ride or walk after the APES exam and just relax and like tie a nice bow on the year, I'd listen to some Frank Ocean. Okay, let's go back to our shoutouts. Okay, we're gonna do 3 minutes of shoutouts. It's at 9:11. Okay. We can do 3 minutes shoutouts. We got to be quick though. Where did we leave off? We left off at Ethan. Okay. Ethan has a shout out for Miss Ashok Kumar or Mr. Ashok Kumar. Drives a catless Hellcat. I don't know what that is. It sounds like a type of car, but your students appreciate you. Okay, this is a heartfelt one. Shout out to Miss Escobedo. She's an amazing teacher, and I'm so grateful that I was able to take her APES class this year. She's an amazing educator. Very heartfelt, very genuine. Thanks for making it a nice, clean shout out. Shout out to Maxa. She's the best teacher in Illinois. Wonderful. We also have a shout out for Mrs. Jansen. We have a shout out for Mr. Boswell, our amazing teacher. I don't know if that's an inside joke. It looks like it because they have a llama at the end. Our amazing teacher. Okay. Stan Luna. Please say Stan Luna, and we'll get a 5. Okay. Good luck, Stan Luna, whoever that is. We also have Miss Buffardi, the best APES teacher, D1, inflatable dinosaur, and a tree hugger. Oh, it's always great when an APES teacher is a tree hugger. Okay. This one's kind of funny. I do like the insult at the end. Eat my shorts. Eat my shorts is like, we need to bring that insult back. Next time someone insults you or does something you don't like, tell them to eat your shorts. Or tell them they're municipal solid waste. That's a good insult too. Shout out the boys from Franzmeyer. We are getting 5s. Eat my shorts. Okay. Okay. Don't worry about curies and watts. You may see kilowatt hours. You should know that there's 1,000 watts in a kilowatt, but don't worry about curies, becquerels, BTUs. Those are probably outdated terms. The other thing I want to say, I don't want to just like directly slander accounts that make APES review content, but like there's some people that make APES review content that I've gotten a lot of emails about, and they're not telling you to review stuff that's going to be important on the exam because they're not teachers. They don't teach the class. They're like college kids that like want to have a startup. So just be kind of careful what sources of information you see online about the APES exam and then start panicking about. I saw one where they're talking about chemosynthesis. They're like, you need to know chemosynthesis for your exam. It's going to be on there. Or they're like, the nitrogen cycle is definitely going to be on there. And it's like, nitrogen cycle is one topic in Unit 1. That's 6 to 9% of the exam. It's very possible you could have no nitrogen cycle questions. It's not on the exam every single year. And you definitely don't need to know chemosynthesis. It doesn't hurt, but it's like, anyway, just don't get too worried about some of the stuff you're seeing online. Okay. Okay. Oh, this is interesting. We have an album rec the other way. Jane Remover. I'll check it out. Love a good rec. Frailty. All right. Great. We'll try to do just a few more, but that was the timer that's supposed to be keeping us on pace to get through Unit 9. But a first-year APES teacher, that's tough. So shout out to Mr. Osmond. Your students appreciate you. We also have Miss Fitz, Ann Richards, and Anwita. We have Miss Camden. Her students at HHS are all getting 5s. The goat, Miss Brager probably. Oh, we have another first-time APES teacher, Miss Pepper, also avid coconut LaCroix. Yeah, this one is strawberry peach, but strawberry peach is very good. Coconut's nice also. Okay, let's see here. Let's do 3 more, and then I'll try to wrap up more of them at Unit 9. And then ones I don't get to tonight, I'll screenshot and I'll add them into tomorrow morning's live stream. Tomorrow morning, 9 a.m. to 10 a.m. We'll do live stream. So some of you might be in class, but maybe you can tune in with your teachers. Okay, so 3 more here. We have a shout out to Miss Comproni at Saugus High in Massachusetts. And then we have Miss Sprague from AHS. Please let us play Taboo again. Taboo is a fun game. That sounds like a good time after the exam. Oh, no. Didn't mean to show that one. No APES teacher hate on the live stream. All right, shout out Miss Jimenez at CGSHS, our APES queen. All right, awesome. So we left off here at this. I'm just making notes on what super thanks I leave off at, so I can try to get them all. Unfortunately, some are not. We're probably not going to quite get there. And you know what? I can respect it. Emma says, pack it up. We're running out of time. Yes, we are here to review. We're here to celebrate the year of APES somewhat, but our primary reason is to review. So let's get the Unit 9 banner, and let's get back to review. Real quick, just because it caught my eye and I need to change the slide. Anyway, Pistons. I'm from Michigan. I'm a Detroit Pistons fan, and they're coming up next. I think they got a good chance in the East over the next 5-10 years. Okay. CFCs. CFCs are going to drive the breakdown of ozone. Specifically, we're talking about stratospheric ozone. So helpful ozone that protects us from UV rays. The chemistry of this can be helpful to know. It's that chlorine atom that the UV radiation hits, knocks the chlorine atom off. Now the chlorine can pull an oxygen off of ozone, and the net conversion is ozone to O2, weakening the ozone layer, exposing us to more UV radiation. The thing to remember too is this is super persistent. So that chlorine atom can do this over and over and over again for a long time and destroy, hundreds of thousands of ozone molecules, or many thousands, up to 100,000. Okay. Solution is replacing them with HFCs that don't have chlorine and that don't damage the ozone layer. All right, the greenhouse effect. This is something to study. If you don't have a strong grasp on the greenhouse effect, one of the top few things I would study tonight, the 9.3 and 9.4 video. So again, if anybody's like taking notes or kind of making a list of stuff to make sure that they go over. Oh, I did catch this one real quick. Montreal Protocol. Yeah. Montreal Protocol was the international agreement to phase out CFCs. And that is a required piece of legislation you have to know. Montreal Protocol, phase out CFCs, replace them with HFCs that don't contain chlorine, hydrofluorocarbons instead of chlorofluorocarbons. Okay, back to the greenhouse effect. These are key verbs you want to kind of try to understand. So we have visible light coming into Earth from the sun. We have all sorts of solar radiation. Visible light's one of them that we can see. What happens is solar radiation hits Earth's surface, and then it's converted into infrared radiation or heat. And that infrared radiation is given off as heat. So we experience it, we feel it as heat. This room's very hot right now. There's lights. I'm yapping. It's hot. So there's infrared radiation in this room for sure. Now, the infrared radiation that leaves Earth's surface goes up and hits molecules in the atmosphere called greenhouse gases. Greenhouse gases have properties of being able to absorb some of that infrared radiation and then re-radiate it back down to Earth, direct it back down. Notice they send it in all directions, but some of that is back down to Earth's surface. And so that phrase is important. They absorb infrared radiation. You can often phrase that as they trap heat in Earth's atmosphere, but I like understanding what the infrared radiation is and the fact that they redirect it or re-radiate it back down to Earth's surface. And that's why our planet is warm and It's why we can survive here. Of course, when we add too many greenhouse gases to the atmosphere, the planet starts to get too warm, and we may not be able to survive in our current geographical distribution. It's not like the Earth is going to get so hot that it's just going to melt into flames and humans won't have any chance of survival. But major disruption is predicted and is already occurring, especially in low-lying coastal areas. And here's the reason, right? Sea level rise. So two causes for sea level rise in a warming Earth, in a CO2-filled atmosphere or a CO2 increasing atmosphere, let's say, because CO2 is still a tiny part of the atmosphere. A CO2-filled atmosphere, we would be probably on fire. It'd be way too hot. But as CO2 levels rise, they trap heat in Earth's atmosphere. That was the greenhouse effect. They absorb infrared radiation, re-radiate back down. Two things happen. The oceans just take up more space. We call that thermal expansion. So there's just more volume because the molecules get further apart when they're hot. So hot molecules get further apart. The ocean takes up more volume. That increase in volume means that sea level rises. Then the ice sheets melt, but we have an important note on the screen you can see here in red. We can't just say that the North Pole, we can't just say polar ice, because at the North Pole, there's no land underneath it. So that ice is already floating on the ocean. So if you want to describe on an FRQ that melting ice is raising sea level, you have to say that this is Antarctic ice or land-based ice or glaciers. But the key is you need to make sure it's known to your reader that you're not talking about the North Pole, because that ice is already in the water displacing sea level. So when it melts, sea level doesn't rise. So it's just an important distinction there. We got to talk about land-based ice melting and flowing into the ocean if we're talking about sea level rise for that cause. Thought I saw a good question here. This is a good question. Yeah, it's typically not asked about on the APES exam. But yeah, without greenhouse gases, Earth's average temperature would be close to freezing. I don't remember off the top of my head the exact average temperature we're going to have, but it'd be very, very cold. Much colder than the like 50 some odd degrees of the average surface temperature on Earth these days, which is, very hospitable to life. So we do need the greenhouse effect. It's just like clothing, though. I try to tell my students the greenhouse effect is like clothes. You need some clothes. You can't go outside with no clothes on. Be too cold, and it's also just not appropriate. So you need to wear some clothes. But at the same time, you don't put shirt after shirt after shirt after shirt on. You get to kind of a medium amount of clothes, like a good, healthy amount for whatever temperature you're in. And then you don't just keep putting on a sweatshirt and a parka and another sweatshirt and another parka. You're going to get way too hot because too much of your body heat's going to be trapped. And so think of that clothes analogy. You need some clothes. It's too cold without them. But you can't just put on shirt after shirt after shirt after shirt. You get too hot eventually. And that's kind of like the greenhouse effect. All right. I want to talk briefly about the unequal global warming. So the poles, especially the North Pole, are heating faster than the rest of Earth. Part of that is the positive feedback loop we talked about yesterday, which I have on the screen here. So snow and ice melt when the Earth heats up. That means that there's less reflection of sunlight by ice and more absorption of sunlight by dark blue ocean water. That, of course, heats the water more, which then heats the air. This melts the ice. Now there's even less ice to reflect sun, so even more sun is absorbed. So the water heats up even more, and the air heats up even more because heat transfers from water to air. The ice melts even more, right? And so as we go, it spirals out of control to the point where you can lose something completely because the output of that system, heat, causes more heat. And so it just spirals out of control. So we call it a positive feedback loop. Okay, next we have coral bleaching. So remember that when the water gets too warm, we have the algae that are the symbiotic or mutualistic symbiont, we sometimes call it. That's the word I was looking for. The algae are what are called a symbiont, meaning they live in the coral reef. So the coral reef is the exoskeleton, calcium carbonate exoskeleton that the polyps, the little animals, build. And then the algae called zooxanthellae, you don't have to remember that they're called zooxanthellae, but they are. It's a fun word to say. They supply the coral with sugar. They supply the coral with sugar, and the coral provides nutrients. So the coral are kind of messy eaters, and they drop little bits of organic matter. So the algae can get some nitrogen and some phosphorus. So it's a symbiotic relationship. It's really good for the coral because they get a ton of their energy, their food source, their sugar from the algae. So those little polyps, those little animals, they really benefit from that. The problem is when the temperature gets too hot, the algae actually start to secrete substances that are like toxic to the coral. And so the phrase you see used a lot to describe it is the coral expel their algal symbiont, or they expel the algae. They actually kick them out of the reef. Now, you usually don't need to go into that level of depth, but knowing that a bleached coral is a coral that's lost its color because the algae have left because it's too hot, it's outside of their temperature range of tolerance where they can function effectively, is usually well enough to explain on an FRQ. But if you want to remember that the algae get expelled, I just think that's kind of funny to get kicked out. It's not funny, actually, it's sad. But when you think of expelled, you think of like a student who did something really bad. And so I just always, whenever you read about coral bleaching and they talk about the algae getting expelled, I'm like, man, what did they do to get expelled? Okay. This is a good question. It's very relevant. Unit 9 is most common on the exam because how much information there is or the importance of the information. It's kind of both, right? This whole course of environmental science builds towards global change, climate change, because it is the culmination of all of the other systems interacting, and especially the human aspect of the environment, right? The environmental science that we study has energy, which is a total human-derived concept. It has population growth in Unit 3, a total human concept. And it has air pollutants in 7 and 8, which are human action outcomes from our actions. And so Unit 9 is the culmination of everything. We want to understand how humans impact global change through energy, through agriculture, through all sorts of things. And Unit 9 is where that happens. So it's a good question. There is a lot of information, but it's also just important information. Okay, don't forget about ocean acidification. So this is different than ocean warming. Both can happen because of carbon dioxide, but with the carbon dioxide, it dissolves into the ocean and forms carbonic acid. So the problem with that is that your calcium carbonate shell builders now have less carbonate ions available because they're losing some of those carbonate ions to the formation of bicarbonate. So the chemistry is usually not a heavy point to emphasize on the exam, but the H+ ions that dissociate or that leave the carbonic acid that forms, those H+ ions bind with the carbonate ion, and you can see this kind of illustrated on screen. So we get more net formation of bicarbonate ions, HCO3, instead of free carbonate ions. And those carbonate ions were what the shell building organisms needed to build their shells. So it's basically like there's a shortage of the carbonate ions needed to build their shells, and that's why their shells weaken or even break under acidic conditions. So again, you have to remember that acid means, in this case, increased concentration of H+ ions. And so that's going to have those H+ ions take away the carbonate ions to form bicarbonate so that the carbonate ions are less available for the shell builders. And so that's the science behind or the explanation. But if you want to just remember the identify level of it, you can at least remember that carbonic acid in the ocean, weakens or dissolves organisms with shells. This is a good question. It's not likely that you're going to have to identify a chemical formula on the FRQ section. It's always possible. There was one of these questions in like 2018, I think. But you could figure it out if you can just balance in a chemical equation. They gave you CO2 and H2O, and you just have to kind of count the atoms up to get to, your carbonic acid formula. It's not a huge point of emphasis. I wouldn't freak out tonight about ocean acidification. Okay, final thing we're going to wrap up with here in Unit 9 is metapopulation. So this is not a huge point of emphasis on the exam, but habitat fragmentation is, and so are habitat corridors and habitat patches. So we have HIPCO, which is this acronym to describe why biodiversity is declining. We've got habitat loss, invasives, population growth of humans, pollution, climate change, and then overhunting or overharvesting. So all those things happen. 2 laws you should know: Endangered Species Act and CITES, CITES. That's basically the International Endangered Species Act, and they prevent, the importing or sale of endangered species on the country level. Endangered Species Act does the same thing here, but also lets the U.S. government buy habitats to preserve these endangered species. And a way that can make habitat conservation more effective is if you connect isolated habitat patches with corridors, because now organisms can move between, and you don't just have a bunch of small isolated subpopulations. You have connectivity. You have organisms able to go and mate or breed with organisms in another habitat, which increases genetic diversity and decreases inbreeding depression. So if you're writing about habitat conservation on the FRQ section, really valuable to be thinking about habitat corridors to connect isolated patches of habitat. It's just going to really make those populations much more stable. Okay, that about does it for the content we had planned tonight. These are some important APES vocab terms that if you're looking for something to review tonight, I would definitely check these out. If you're concerned about environmental legislation, it's usually not a huge part of the exam, but it has shown up on 2 different FRQs in the last 4 years, just a 1-pointer. Actually, 1 year it was 2. And then I don't know what shows up on the MCQ, because MCQ questions aren't publicly released, but it's fair game to have a piece of environmental legislation on the MCQ. So here's what I have to say about legislation. I would not spend more than 5 to 10 minutes on it, maybe 15. But if you really want to check it out, I have a 5-minute video that's going to give you like 3 facts per piece of legislation. And that's really about all you'd be expected to know. They're not going to tell you to like give the sponsor of the bill and the state it originated in and the enforcement agency and everything. So if you watch that, it's basically a stitch of a bunch of TikToks. It's like 3 to 6 minutes long. But that video, which is linked in these slides, slide 58, if you go in the video description, that'll have the legislation TikToks. And again, there's nothing super complex with them. It's a few key facts for each one. Okay. That just about does it for the content. So we've covered Unit 9, the biggest unit. And we got one more album recommendation, Phoebe Bridgers' Punisher. This album I listened to all the way through every morning when I was working on the Ultimate Review Packet years ago. So great album, especially the final song. It's very cathartic, so you could listen to it tomorrow afternoon when you're done with your APES exam. All right, so let's do a few more shout outs, but then we have to switch over to the Ultimate Review Packet exclusive live stream. So that'll happen in basically when I'm done here. So in a few minutes. So let me try to pick up with a few more shout outs. Oh my gosh, there's so many. We're definitely not going to be able to get them all, but what I'm going to try to do is pull some of them into the tomorrow morning's live stream. So we'll try to do some there. Okay. Where did we leave off? Left off at Bree. Okay. So we have Miss Jimenez at CGSHS, their APES Queen. Oh, look at that. Shout out to everyone at GRP APES. This is Grand River Prep. This is where I teach, if it's who I think it is. Wonderful. I've got a great group of APES scholars this year. They really are a phenomenal crew. Go Titans. Go GRP, if this is my GRP. Shout out to Miss Miranda, best APES teacher in California at GHS. Awesome. We have Mr. Armour from Boynton Beach. Very cool, Mr. Armour. Your students appreciate you. Let's see here. All right. Again, some of these are unnecessary, you guys. We're not doing every single one of these. Shout out to Mr. Cram in Utah. Utah is a beautiful state. I've spent some time in Utah. I love the scenery there. Zion's beautiful. Capitol Reef is a slept-on national park. Definitely check that one out if you're in Utah. Shout out to Mr. Andrew J. Lee. Oh, you're using the teacher's full name. Okay, best teacher. We have a shout out here to Mr. Buford and all the students' classmates. Oh, Nate. Nada's getting even more specific and giving a D-Hour shout out. D-Hour is a great group of scholars this year. They are. I feel like we've gone through a lot in D-Hour. It's a great group. All right. Shout out to Miss Thompson, best APES teacher in Houston. So helpful and nice, even when the class is acting up. That is heartwarming. Even when the class is acting up, a teacher still keeping their cool is wonderful. From Robbie, David, and Tyler, shout out to Miss Turner. We love you. Also, sorry for spelling your name wrong. So they spelled your name wrong at some point, Mrs. Turner, and they're sorry. All right. Top Dog Kelly from a bunch of places. Thank you for everything. We have a shout out for another Mrs. Kelly shout out. So Mrs. Kelly, your students are proud of you. Oh no, shout out from Mrs. Kelly to her students. Sorry. Shout out to Mrs. Kelly's students from BHS. She's so proud of you. It's been an honor to teach you in APES this year. That's funny because it sounds like they actually got back-to-back shout outs from the teacher to the teacher. So good job, Miss Kelly. Mrs. I want to say legumes. Lagunes. I'm probably saying that wrong, but they're the best. Dr. K, best APES teacher. So elite. Again, some of these comments are unnecessary. They're not going on the screen. But try to keep the shout outs rolling. We have Mr. Ashok Kumar says, shout out to Mr. Ashok Kumar. Oh, no. Oh, here we go. Okay, I need to read these whole things. The problem is I'm scanning for stuff I shouldn't have put on the screen too fast. So Mr. Ashok Kumar says, Amir Jamula, you're just doxing your whole name here. Okay. From the high school that you are at, is a better point guard than Steph Curry and LeBron combined. So that's high praise from the teacher to this student. Again, I don't love the docs and the whole name of the school on the shout out. So I might maybe hold those ones out. But anyway, Mr. Roberts from North Carolina, he's the best. Okay, we're gonna do 3 more, and then ones that come in after that, which there's still quite a few of, we're going to pull into tomorrow's live stream. So shout out Mr. Roberts. We have shout out Pope AMS cohort, also Mrs. Malafronte. Shout out to Mrs. Malafronte. Shout out to Miss Davis. Your students love you. Horse emoji. Shout out to Mr. Medlin. And okay, 3 more, and then we're going to save the rest for later. Miss Camproni at Saugus High School in Massachusetts. That's another one. Someone already shouted her out, so our students really appreciate her. Shout out to Mrs. MC from Steel Canyon. Your students are big fans of you. And then finally, we're going to end on this note. This is Mr. Figueroa at Jersey Village. And I assume the 5 is we're going to get 5s. So I'm going to take a note of where we left off because these all stay in order. And we're going to come back to these tomorrow on the 9 a.m. to 10 a.m. live stream. Okay. So we are wrapping up here. We are going to switch over to the Ultimate Review Packet live stream. So if you have the Ultimate Review Packet or the Ultimate Exam Slayer, you can head over there, and that live stream will be starting up soon. I need a little bit of a break, so it'll probably start at like 9:50 and go till 10:20. But that's it tonight. That's it for the presentation. Oh, that's right. A couple honorable mentions. So people that I couldn't fit into the recommended albums, but music you can consider listening to. as you're relaxing, unplugging from the exam. I'm not going to go through and talk about every single one of them, but great artists there on the screen. But basically, I just want to say it's so much fun to make environmental science videos and share them with you guys. I'm really impressed and amazed when I see how many people show up to try to study for their exams, the questions they ask, the scholarship they're bringing here. And for a lot of you, the passion that you're bringing to for environmentalism, which is not part of the course really, but we hope that your interest in environmental science and your knowledge for environmental science carries over into also wanting to make the planet a better place. We all have to share the planet. And so the knowledge that you're gaining in this course can go with you, well beyond your exam score, and hopefully help you live a little bit differently in the communities that you go into. You're going to have schools in the future. You're going to go to churches. You're going to go to workplaces. You're going to be part of neighborhoods. You have decisions to make about how to use resources. And the hope for myself and so many of your APES teachers is that what you learn leads to science-based decisions that you make in organizations that you're part of, and that you can hopefully make the organizations that you're part of more sustainable, and make sure all of the beautiful aspects of this world that we all enjoy are here for our kids and their kids and future generations. That's sustainability in a nutshell. So with all the information you've learned, I hope that you take it with you into the future. And I hope that you always remember to think like a mountain and write like a scholar. Take care tonight, and we'll see you on tomorrow morning's live stream from 9 to 10 a.m.